Bismillahirrahmanirrahim. Inshallah, we'll go on with question number 41. So this question says, what is the median of the following 7 scores? So this is regards to mean, median, and mode. Of course, mean is the average of certain numbers. Mode is the middle number of a set of numbers. But you have to keep one thing in mind. So when you're trying to do medians, you're trying to find the middle number, you have to arrange the numbers from the smallest to the largest first. Okay, and mode is the most common number. Okay, so in this case, then first we have to arrange these numbers from the smallest to the largest. Okay, so that would be before we find the median. So it's 21, and then the 33. There's two 33s. I mean, you should write both of them. 42 and 67, 79, and 89. So those are the numbers, and there's 7 of them, and the middle number is 42, and that's the median. So the answer is A. Now, what if you had like even number of numbers? For example, if you had like 6, 12, 14, and 18, 19, and 20. So this is even. There's 6 numbers. There's no middle per se, right? There's no number here in the middle. In this case, you take the average of the 2 middle numbers, and that will give you the median. Okay. So the mode is the most common number. In this case, the mode of this set of numbers happens to be 33 because there are two 33s. For a given set of numbers, there could be no mode. In other words, if each number only shows up one time in the set, then there's no mode. There's no most common number. If in this set there were 2 numbers that showed up twice, like 33, 33, and then 79, 7, and this would have 2 modes. That would be 33 and 79. So mode is the most common number that's found in the set. Median is the middle numbers after the set of numbers is arranged from the smallest to the largest. Okay, so that's a question number 41. Question number 42 is like over here. Okay, what are the real solutions to the equation? So here you're given a quadratic equation with absolute values. Okay, and you're asked to find out what's the real solutions, and you're given these choices. One way of doing this is just plugging these numbers and say which one works. It looks like it's going to be 1 and 3 or some combination thereof. So in fact, that's the first thing I did because I tried them out. If you put 1 in there, see 1 squared is 1 plus 2 times the absolute value of x is 1 and minus 3, and that ends up being a solution. But this is an interesting question, so let me write this question, x squared. Notice I actually made a mistake here as I was copying down. It's not x squared absolute value. It's absolute value of x that is being squared. So these two are not equivalent. In fact, I made a critical mistake when I was copying this down, and hopefully that could be instructive for you. So the question is absolute value of x squared plus 2 times absolute value of x minus 3 equals 0. What are the solutions for this? Okay. Now, this is different than this, which was the mistake I made. That would be a very different question. So we are asked to see what are the solutions. It looks like there will be some combination of 1, -1, and 3, -3. But this might be difficult for you if you look at it the first time. But you're very familiar with solving quadratic equations like this. If you had a quadratic equation like this, the easiest way to solve this would be to factor this out, and this factors out to be like this. Okay, so 3 and 1, the inners and outers, and in the inner and outer would have to add up to, and so add or subtract to give you 3 in this case, right? So the inner is 3, the outer is 1, and they do in fact subtract to give you 2. This says the signs are different and the bigger one is positive. I'm just making sure I copied the question correctly, and I did. The signs are different. The bigger is positive, so it's going to be like this. Okay. So from here I get x plus 3 equals 0, or x minus 1 equal to 0, x is equal to minus 3, and x is equal to 1. So these are the solutions to this quadratic equation. So there are also going to be solutions to this, maybe, okay? Because of the absolute values, some of them might work and some of them might not work. For example, if you put a negative 3 in the absolute value equation, if you put both of these values here in this equation, they will both work, okay? But if you put a negative 3 in that equation, like this, okay, I'm not sure if that would work. So let's see what happens. So negative 3, now absolute value of negative 3 is 3. And that's being squared. Okay, so 2 times absolute value of negative 3 is 3 minus 3. Now does that equal to 0? Okay, negative 3 squared is 9. That is 6 minus 3. And that does not equal to 0. Okay, this is not. So negative 3 is not a solution to this. Okay, so negative 3 is not a solution to this. It's a solution to this, but it's not a solution to the absolute value equation that we're given. How about 1? Well, 1 will work because it works for this. So absolute value of 1 squared plus 2 times absolute value by 1 minus 3. Let's see what happens then. This is 1 plus 2 minus 3 equals 0. And this is 3 minus 3 equals 0. And that works. But the tricky thing is this. So this definitely is the answer, at least one of the answers. But if you go back to the question, it gives you 1. So you can basically exclude all of these answers out because they all have some 3 over there. See, and then this one is out. So F is an answer by default. But you notice that it's plus or minus 1. Okay, but we only got 1. But the absolute value of negative 1. Okay. Sorry, it's absolute value of negative 1 is 1. So that's why absolute value of negative 1 also works. So the solution then ends up being plus or minus 1 for this equation. That's a good question. Okay, now let's go to this over here. Question number 43. Okay. The point 25 is shown in the standard XY coordinate plane. That's this point is shown in the standard XY coordinate plane. Which of the following is another point on the line that goes through here with the slope of this? It looks kind of complicated question, but all they're asking here is the bunch of points that are given, like in a shotgun point. Which one of these is also happens to be on the line? Okay, so let me go over here. So now, so this is the point given, and you want to know which one of these other points is also on the line that has a slope of negative 2/3, okay? Well, slope of negative rise over run means you go down 2 and over 3, and that's D. In fact, it's the only point that's that would be on this line, okay? That goes through between here and here, kind of like that kind of. So it's D. The answer is quite simple. In that way, it ends up being like that. It looks like a more complicated question than it actually is. So, point given and then the slope. That's hopefully. Now, this question is an interesting question, and I like this question. It says for the triangles, okay, in the figure below, which of the following ratios, all of these over here, okay, of the side length, so these are the ratios of side lengths, is equivalent to the ratio of the perimeter of ABC to the perimeter of ABC, ABC, the small triangle, to DAB, this triangle over here. So those are the two triangles you were talking about. Now, if you don't know the geometry that's behind this question, this is a very difficult question, but if you do know the geometry behind this question, it's actually not that bad of a question. So what is the geometry behind this question, you say? Well, it's this. It has to do with similar triangles, okay? So here's, I'm going to try to draw actually two triangles that are meant to be similar. You know, you have to give me, they're meant to be similar. You know, I'm trying here. So pretend these are similar triangles, okay? So if this is 2, this is 4, and this is 5, so if this is 4, this is 8, and this is 5, this is 10, okay? So these two triangles are similar, okay? If two triangles are similar, so they're all multiplied by 2, see, okay? If two triangles are similar, okay, then the sides are in ratios. In fact, when any two figures are similar figures, okay, whether it be triangles or pentagons or hexagons, when you have two figures that are similar, they have two qualities, and you have to know this. They have two qualities, okay? The first quality is that all the sides are proportional. In other words, 2 over 4, that's this over this, okay, equals the proportion of these two sides, 4 over 8, okay, and that equals to the proportion of this side, which is equal to 5 over 10, okay. This is 1/2, this is 1/2, this is 1. All the sides are proportional, okay. That's one. So if two figures are similar, the first quality that they share is that all their sides are proportional. The second quality that they share is that all the angles are congruent. The angles are congruent. All the corresponding angles, okay? All the corresponding angles, these are corresponding angles, okay, are congruent, okay? Which means this angle is congruent to this angle is congruent to this angle, and this angle is congruent to this angle, like that. So when two figures are similar, all their sides are proportional and all their angles are congruent. And this you kind of like just have to know. I mean, that's like the definition of similar figures. And now when you have two similar figures, then whether it be triangles or pentagons, hexagon, whatever, if there are two similar figures, okay, there are some things that you have to know. See, the sides are proportional, correct? So let's say the sides are proportional, like A over B, for example. The first triangle like this I drew, the other triangle I drew, this is A, and this is B. So this side to this side is A to B, okay? So the sides are proportional like this. See, many other things are proportional. The sides are proportional, okay? And then the perimeter, okay? The perimeter is also proportional, and this and the proportionality factor is the same, A over B. The perimeters are the same, A over B. The perimeter is the same. And then the areas are also proportional. But the ratio of their proportionality is A squared over B squared. And if it was a three-dimensional figure, if it was a solid figure, their volumes would also be proportional. And the ratio of proportionality would be A cubed over B cubed. Okay, so this is key, and this is beautiful, I think. So if two figures are similar, the sides are proportional, and their ratio is this, and the perimeters are proportional, and the ratio is the same. So the ratio of the sides and the perimeters are the same, okay? So that's the key in this question. Okay, the areas are proportional, the ratios of proportionality is that. So if I were to redraw my little figures over here, which I tried to do earlier, okay, let me try to draw these two triangles out. Okay, so I had said that this is 2, this is 4, this is 4, this is 8, this is 5, and this is 10. So the ratio of the sides, okay, was 2 to 4, wasn't it? It doesn't matter which you pick, which is 4 to 8 and 5 to 10, but you can pick any side because they're all going to be the same proportion, which is 1 over 2, right? So, and the ratio of the sides is 1/2. The ratio of the perimeter, as I said, is also going to be the same thing. So the ratio of the sides is AB, and the perimeter is also going to be the same ratio, which is going to be 1/2. The ratio of the areas, if you were to extrapolate this, is going to be what? It's going to be A squared over B squared, okay? In this case, it's going to be 1 squared over 2 squared, which is 1 over 4. This is the area of the proportional. This would be the areas would be proportional like that. So if the area of this figure is something, the area of this one is 4 times as bigger as that because of this. Okay, the perimeter is going to be the same ratio. Okay, so with armed with that knowledge, see, now we can go try to answer this question. Now here it says, for those two triangles in the figure below, which of the following ratios of side lengths is equivalent to the ratios of perimeter? So if you knew the geometry behind this, you know, okay, you're talking about similar triangles, okay? So you're talking about similar triangles. And then you know that the ratio of the sides is going to be the same thing as the ratio of the perimeter, right? So this is the ratio of the sides, and this is going to be the perimeter. They didn't ask here, but the ratio of the area is going to be square root of that. Now you have two triangles that are similar. So there are two 30, 60, 90 triangles here. That's 30, and this side is going to be over 60, and there's 60 over here, and this side over here is going to be 30. So there are two 30, 60, 90 triangles here, and they are similar. Now you have to be careful, okay, because this one is right side up, so to speak, and this one is like flipped, right? So if you, it's kind of like fallen. If you were to rewrite this and redraw the smaller of the triangle, okay, it would be kind of like, you know, like this, right? So, okay, you get the idea. So you have to be careful. That's the only thing you have to be careful. Then you know all the sides, all the corresponding sides are proportional. Let's see if that's the case. F, all right? So F, AB is proportional to AD. So AB's this is proportional to AD, okay? Is that the case? Okay. Well, now if you considered AB to be the part of the smaller triangle, that's the side opposite of 60 degrees, right? Okay. And AD over here is the side opposite of 60 degrees over here from the big triangle, correct? So those are corresponding sides. So these two sides, AB for the small triangle and AD for the big triangle, they're both sides that are opposite of 60-degree angles. So they're the corresponding sides, okay? In other words, if you were to line up these two triangles, like, okay, and this was a 60-degree angle, one of them would be like that. They're corresponding sides. So their ratio, the ratio of AB to AD, will also be the ratio of their perimeter. So you just have to make sure to get the right perimeter of ABC, which is a small one, to DAB, which is the big one. So that works. So in fact, this happened to be the correct answer, the first one. Let's see what the other long answers are, if that's correct. So this is the ratio of the sides, which is equal to the perimeters. Now AB to BD, so that's AB over here to BD over here. That makes no sense because they're not the corresponding sides. That's the side and that's the hypotenuse side. Okay, that's like saying this side to this side. They're not corresponding sides, so that doesn't work. AD to BD. Sorry, AB. So AD, which is the big side over here, from AD to BD. That makes no sense because that's part of the one big triangle. All right, BC and AD. BC and AD. That doesn't make sense because they're not corresponding side, because BC is the side across from 30 and AD is the side across from the 60 for the big triangle. Okay, and BC and BD. BC and BD. That doesn't work because it's the small side over here and that's the hypotenuse side. So the only one that's actually correct is F. So this is a very nice question. It's a question that tests whether or not do you know what it means for two triangles to be similar, and that means the sides are proportional, okay, and the angles are congruent, correct? That's what for two figures to be similar. And you have to know the side ratio is the same thing as perimeter ratio, and areas ratio is the same, is the square of the ratios of the sides, okay? Okay, that's that. Question number 44. Question number 45 says, in the figure below, non-adjacent sides of a regular, so this is a regular pentagon. This is important here. So the regular pentagon, which means, what does regular means anyways? Okay, when you say a regular, that has two connotations. Okay, regular means all the sides are congruent. Okay, it means all the angles, all the corresponding angles. Let me see angles. That's the corresponding angles. Angles are congruent. Okay, so like this. I didn't draw it like this, but all the sides are congruent. Okay, and all the angles are not corresponding angles. All angles are congruent. We're talking about regular figures. Means all the angles are congruent. All the angles are congruent. And all the sides are congruent. So all sides are congruent and all angles are congruent. Regular figure. Okay, so that's what we got here. Okay. Now they're extended until they meet at point S. So this one is extended, and they meet at X. Okay. What's the measure of angle X? So you're asked to find that angle. Okay. Well, how are you going to do that? Well, you can find this angle if you know what this angle was and if you know what this angle was. Okay. And that's what this question asks. This is a favorite question. So let's just try to draw a regular pentagon. Okay. This is how I remember this topic. Okay. So this is a regular pentagon, it's supposed to be. Now, all the sides are congruent and all the angles are congruent. So the way to do this question, so you have to figure out what these two angles are over here. You have to know what this is. Okay. In order to do this one, you have to figure out what this angle is and that angle is. But they are going to be the same because it's a regular one. But that's what you have to do. So first thing you have to do, you have to figure out what that is. Okay, so and then the question is, how do you do that? Well, there's a formula for it, but I don't remember the formula necessarily. What I do is, okay, this is how they do it. You put a point in there. It doesn't matter where you put the point, right? And then you draw triangles out there. So you draw this triangles. You draw as many triangles as there are points in the figure. Yeah, but, these are theoretical. These are supposed to be lines, right? They look like awful lines, but let's see. So you draw these triangles out, okay? Now we're only dealing here with the pentagon, so I might as well erase this so I don't confuse you anymore. So we're trying to find the interior angles. So we find the interior angles. So I'm looking for this angle, okay? But to do that, this is what you do. Now you understand that if you add up this angle and 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 this angle, all of those angles, tiny angles, they will give you the sum of all the interior angles, right? So that'll give you the sum of all the interior angles, correct? Yes. So that's what we're going to do. So what we're going to do on the other hand is that, see, now you have 5 triangles, right? And each triangle has 180 degrees in it, correct? So if you take this angle plus this angle over here, and this angle here, okay? So each triangle is 180 degrees, okay? So what we're going to do here is you're going to add up, I'm going to call this sum, I'm going to put dots there for those, okay? So I'm going to add up all these little x's over here and all these dots over here. And that the way they're all going to add up to this. There's 180 times 5. There's 5 triangles, okay? All of these are contained, and each one is 180 degrees. So all these angles are contained. So if I add all of them up, okay, that will give you all these angles. But you see, I don't want all the angles. I just want these x's. I don't care about these because I invented those angles. Because if I were to erase this over here, okay, if I were to erase this, I get the sum of all the interior angles, right? Correct? I get the sum of all interior angles. So then I have to subtract all these dots. Well, how much is that? So because if you go around here, that's like, oh, that's 360 degrees. So that's 360 degrees that I have to subtract. So if I add all of them up, which is all these triangles up, that's 5 of them, 5 times 180 degrees. And then I subtract these 360 degrees. Then I get the sum of all the interior angles. Then I get the sum of all of these. Okay, the sum of all of that. So how much is that? So 180 times 5, and then I subtract 360. That's 540. Okay, so this is 540. Now that's the sum of all of them. So the sum of all the interior angles is 540. Well, how many do I have? I have 5 of them. So if I divide this by 5, So 540 divided by 5, that's 108. Okay, 108. Okay, I get 108. Now 108, that's the measure of each one of these individual angles. So if I were to go back over here, see, this angle ends up being 108 degrees, and that's the same 108 degrees. Okay, so now let me go back to the original question. So the part 1 of this question, the way we were solving, okay, is this. You had to find out what this angle was, and we found out that was 108 degrees, and that's the same thing as over here, 108 degrees. Once you know that, these are supplementary angles. So this angle is supposed to be a line. This should be 72 degrees, and that's supposed to be 72 degrees. And then you can find x easily, because x is going to be 180 minus 72 minus 72, right? So let's do that. So 180 minus 72 minus 72, that's 36. So x is going to be 36 degrees. So it looks like this. Okay, so this is a very, I like this question because it tests several things. This is what it tests. Okay, now it tests your ability to find two things. When you're given a polygon like this, okay, you have to have some concepts that you understand. You have to be able to find the sum of all the interior angles. Okay, the sum of all of these interior angles. Okay, the way you do that, the way I do that, is I draw these triangles, and the number of triangles you're going to draw depends on side. In this case, it's 5. So there's 5 triangles, 180 degrees each of them, and then I subtract the middle part of it to get the sum of all the interior angles. Okay, all right. Okay, and the formula, if you wanted to know, was, you can like derive this, because n times 180 minus 360, like that, right? So and you can factor out 180 degrees from here, right? So but I just do it like this because I just think it's easier that way to remember. So that's the first thing you have to understand. So now, if it was not a regular polygon, then you can't say what each of them are. So if I have a pentagon that looks like weirdly odd like this, 1, 2, 3, 4, 5, it's not a regular pentagon. But you can still find the sum of all the interior angles. That's the same process. If it is regular, you divide this by the number of sides and you get the individual angle side. Okay? So that's the one thing that you have to be able to do, sum of all interior angles. The second thing you have to understand is that this is the exterior angle. The way you find the exterior angle is by finding this one interior angles and understanding that is supplementary of this interior angle. And one extra bit of knowledge here is that the sum of all interior angles is a process like this you have to go through, but the sum of all the exterior angles, okay, sum of all the exterior angles is always the same, and that's 360 degrees. Okay, in other words, now what is an exterior angle? Okay, so let's try to draw another pentagon here. So if I take exterior, if I extend this side over here and 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 this side over here, these are all exterior angles. Okay, there's one for each corner. There's actually 2 at each corner, you would say. If I extend this one, there's another one over here, right? But these 2 are the same. See, they're vertical angles, so you only pick one. So the sum of all the exterior angles, the sum of all of these, okay, we're always the same for any side. If it's pentagon, hexagon, octagon, whatever, n-gon, it's going to be 360 degrees. So that's easy enough. But this question didn't test for that. It tested for this. Okay, that's question 45. Okay, so let's do 46. The edges of a cube are 3 inches long. What is the surface area in square inches of this cube? That's easy enough, I think. The edges of a cube. So you have a cube like this. Each side is 3. Okay, so. And then what is the surface area? Now, a tendency might be for somebody to do the volume, which is the side cube, which is 3 cubed, right? That's 27, right? But that's not what the question asked, okay? The question asked for the surface area. In other words, how much gift wrapping paper you would need if you were to do that, if you were to gift wrap this cube. Well, the surface area is going to be area of each side, or each face over here, and that, which is 3 times 3. And how many of those you have? Well, you're going to have 6 of those faces of this. So it's going to be 6 times 6 times 9, which is 54. That's the surface area. Okay. All right. So now, if this was for example, a prism. This is a square prism, for example. I'm trying to draw here. Okay. A prism is a solid geometrical figure which has 2 sides, 2 bases. In this case, these are supposed to be like square prism, and kind of messed up there, but these 2 sides are that side, that base. These are the bases. They're supposed to be the same. Okay, if we can get it here. All right, it's like more like this. You get the idea. Artistic rendition. Okay. So if this was the length and the width and the height, the volume would be length times width times height, right? That's clear. But the surface area, well, you have to add up all the sides, the area of the sides, and then add the 2 bases. So that's how you get the surface area, total surface area. Okay, that's question number 46. Question number 47 says, a number is increased by 25%, and the resulting number is then decreased by 20%. What is the final number? Okay, this is a nice question. So, and some number, okay, is first increased, okay, by 25%, and then whatever you get, that number is decreased by 20%. The final number is compared to the original one. How big is it? Okay. Well, it's like this. Let me try to explain this. Okay. Let's say I have, this was the original number, right? Okay, it was first cut by, it increased by 25%. Okay, let me do it like this. Okay. All right, so first it was increased by 25%. You take 25% of this, and then you add it up to this over here. Okay. And then whatever was over here, you took, okay, so you took 20% of this, okay, and then, and whatever that turned to be, and then you cut it, okay. How much is what's left in the end? Is it like this much, or is it like this much, or whatever, you know what I'm saying? Okay, so that's the question. Okay, so the way I did this is, okay, the original change was 25%, okay? Oopsie daisy. Hold on for a second. So original change was 25%. So if it's like if you went shopping, if something was, it's like, you know, X dollars. If something was X dollars, okay, and then how much, if the price was increased by 25%, how much would you end up paying? You end up paying 1.25, see? Okay, just like you have to know, if something's 25% off, that means you end up paying 75% of the original price, right? Well, if something is marked up by 25%, you'll be paying 1.25% of the original price, right? Understand? So if something was marked up, okay, it was increased by 25%, that means the final price was 1.25, okay? And then if something was marked down by 20%, okay, that means that what you had to pay was 0.80 of the original price. So whatever the original value was here, it was increased, so it became 1.25, and then it was decreased by whatever this was, and 80% of that will be left, 0.80. So all you would have to do is you have to multiply these two numbers and you'll get the value, okay? So what is 1.25 times 0.8? 0.8. It's 1. Okay? So the answer is 100%. You get back to the original price. Well, wait a minute. That doesn't sound right, right? You say, because you increased to 25%, don't you have to go down by 25? No, 20% of the new value. So you go increase by 25%, okay? Then you have to go down only by 20% to go to the original value, and that's this. So you increase by 25%, that's the final number, and then you decrease it by 20%, so 80% will be left over, and that's this, and that ends up being her original price. So it's the same number, you get back to the same number. That's 47. Okay. 48 says, two numbers are reciprocals if their product is equal to 1, like 2/3 and 3/2. Okay. If x and y are reciprocals, x is greater than 1, then y must be what? So if x and y are reciprocals, okay, they multiply to give 1, right? So x times y, they have to give 1. And x is greater than 1. Let's just give an example, like 3/2, okay, 2/3. Then what must be true of y? Okay, y is less than negative. What's up with that? That makes no sense. Okay. If x is greater than 1, that's actually, by counter example, it's wrong. And between 0 and -1, that's also wrong. Equal to 0, this just makes no sense because you multiply and get a 0. Between 0 and 1, see, that is the answer. Because if this number is bigger than 1, that's what that means, if it's greater than 1. If you flip any number that's bigger than 1, the reciprocal of flip number will be less than 1, okay? But it's not going to be negative, so it's going to be between 0 and 1, okay? So if you flip a number that's bigger than 1, the reciprocal will be smaller than 1. But it's not going to be a negative number. How are you going to take reciprocal of a positive number turn into a negative number, right? So it's going to be between 0 and 1, okay? 49. The number line graph below is the graph of which of the following inequalities, okay? So this is a compound inequality. This one says here basically x is greater than or equal to 3, and this one is saying x is less than or equal to -1 because they're both filled. So that's what we're looking for. Now the only thing here is that a student might get confused, is that it's not written in this form. It's written like 3 is less than or equal to x. Okay, so you just have to flip these. Okay, and -1, okay, is greater than or equal to x. When you're switching these, you can always flip them, you know, to make it easier to read sometime. Just make sure the mouth of the inequality is facing the right way. So this one, the mouth was facing the x, is still facing the x. Here the mouth of the inequality, the Pac-Man inequality, is like facing -1, it should be facing -1. And the pointy end was towards the 3, and the pointy end is towards the 3. The pointy end is towards the x, the pointy. Then you know you're talking about the same thing. So you can just rewrite them so it's easier. So you're looking for -1 is greater than or equal to x. Okay, that, so far so good. So that's out. And 3 is less than or equal to x. 3 is less than or equal to x. Okay, so that's that. So this one tests you, can you read the inequality, and also I think it's testing whether a student is able to simply flip something x is less than or equal to -1 to rewrite it, so maybe it's easier for them to read it like that. Okay, 49. Question number 50. all of the following graphs have equal scales on the axes. One of the graphs shows only points for which y coordinate is less than the square of the x coordinate. It says y coordinate is 1 less than the square of the x coordinate. Okay, so that if you were to write that, if you were to transform that into an expression, that would be y coordinate is 1 less than, okay, 1 less than the square of the x coordinate, like this. Okay, now if you were to do that, that's the first part, okay, then it's easier. And if you know that this is a parabola, then that's also super easier. If we didn't know that, this is a very tough question. Then you can, if you did not know that, I would guess you would have to, like, you know, try some of these out, and then by trial and error you would get to where you want to be. And if you know that this is a parabola and you know how to graph this, the answer becomes quite apparent. For this, and this is not a parabola, that's not a parabola, and those three are parabolas. Okay, then you have to pick those three. Among these three, which one is this? Well, if you know parabolas, then you would know that the answer is this, because this parabola is like that. Okay, so now to understand that, you have to know parabolas. So parabolas, the parent equation for parabolas is this, as you recall, and that's the basic equation. Okay, so you have to be able to manipulate the parent equation of the parabolas a little bit. Parent equation meaning the most basic fundamental form of that quadratic function of parabolas. If that's y is x squared, then y equals negative x squared is a mirror or image of this graph, like this. Okay, that's one thing that you have to know. So and then if that's y equals x squared, then y equals 3x squared compared to this graph, this is a what? This graph goes up faster, right? If you can just imagine, would you rather be paid this, or would you rather be paid this? You rather be paid this, assuming that you want to make money, and so you can give to charity. So that would be like this. You can give more to charity. So inshallah. So that's that graph. So that's the difference between this parent graph and this graph. And then to answer this question, you had to know this. If that's the parent equation, what's this? X squared minus 3. Well, that's the parent equation. This equation is just the parent equation moved down by 3 units, like this. Okay. This question asks this: y equals x squared minus 1. It's the parent equation moved up by 1. Okay. So if you knew here, if you knew that this is a parent quadratic function, and you knew this basic manipulations of the quadratic functions, this becomes a very easy question for you, inshallah. So that's question number 50. Inshallah, after a short break, we will go on with question number 51 and finish this off, inshallah. Until then, as-salatu was-salamu ala rasulillah, alhamdulillahi rabbil alameen. Assalamu alaikum.